numerator is the determinant A, B, C, D, E, F, G, H, I. And the numerator is what you get when you replace the constants in for the x column. So it would be like J, K, L, B, H, C, F. Similarly, y has the same denominator. It's the determinant of the coefficient matrix, and the numerator is what you get when you replace the column of constants JKL in for the y column. So you can also solve 3x3 systems of equations in just one step, but that assumes that determinants counts. Taking a determinant counts as one step, which is kind of
yeah, it's kind of wild.
Yeah. Okay, so now I stick JK in first. Does everyone see the pattern? Okay, I'll take that as a yes. Okay, so here comes the proof. Proof. Well, again, I'm just going to prove the x case. And I'm going to interpret it as saying that if I take a determinant and multiply it by x, I get that determinant. Okay. Actually, I'm going to start with the right-hand side and show that it's x times this. Okay, well, okay, let's start. So here comes the proof beginning. So this is J, K, L, B, E, H, C, F, I. I would like to prove that this determinant equals x times that determinant. And what am I allowed to use?
That thing.
That thing, right? I'm allowed to use this system of equations, of course, right? So I know the definition of J, K, and L. The definition of J, K, and L is that's J, that's K, and that's L. So what's the only thing you could possibly think of doing?
Put them in. Oh no.
Put it in. Yeah, put it in. Yeah, so in place of J, I'm going to write AX plus BY plus CZ. In place of K, I'm going to write DX plus EY plus FZ. And I have GX plus HY plus IZ. Okay, and I have BH CFI. So I have this disgusting determinant, which I hope to reduce somehow. Okay, here is where we're going to make use of our various determinant properties, which we proved on the front board. We proved them for the 2x2 case, but we're going to assume they work for the 3x3 case also. So, what's one thing we're allowed to name all the things we're allowed to do that don't change the value of the determinant at all? Oh, sleep in 6 minutes. Not yet.
Yeah, but we do the column adding stuff.
Column adding stuff, yeah. What should we do?
Adding stuff.
I can the hand. Stretching.
Add things to the column.
Add things to the columns, yeah. What might I want to add to, like, which column feels like it needs some work? Yeah, Fausto.
The first column, I would add negative PY minus.
You can't just throw in random.
Yeah, let's do one at a time. You got the right idea though, right? Fausto says, yo, let's replace column 1. Replace column 1 with, we're allowed to do this, right? We're allowed to replace a column with the sum of it and a multiple of another column. So replace column 1 with column 1 plus
Negative y times b.
negative y times column 2. That's something we're allowed to do, right? We proved that the determinant is unchanged if you replace a column with the sum of it and a multiple of another column. Okay, replace column 1 with the sum of it and negative 1 times column 2. Negative y times column 2. that does not change the determinant, what do we end up with? Well, it kind of went in like a weird order a little bit. I was listening too fast. That's fine. Does everyone see if I multiply column 2 by negative y and add it to column 1 and replace column 1 with that, then I end up with this.
Do the same.
You're supposed to go, oh. Jeff G, now what?
Place another column.
No, you,
Do the same thing with X.
No, she did the same thing with Z.
With Z, yeah.
Oops.
Replace
X.
column 1 with, replace column 1 with column 1 plus negative Z times column 3. So multiply column 3 by Z and add it to column 1 and replace and change putting column 1. Yeah, you can suddenly I end up with AX DX GX BEHCFI. So everyone see how we got that? Okay, final step. One more property of the determinant. What's the other? Yeah, Fazio.
you multiply by 1 over x.
Wait. One of the very first one we did was that if you multiply a column by a constant, it changes the value of the determinant by that constant.
So you multiply the column by X.
Yeah, so you multiply that column x. So this is really just x times A, D, G, B, E, H, C, F, I. Ta-da! Conclusion, we just proved that the JKL determinant, basically just using 3 properties of the determinant, we proved that this is just x times A, B, C, D, E, F, G, H, I. And thus, Cramer's rule follows by just dividing through both sides. By this. All right. That is a proof of Cramer's rule in the 3x3 case. This is a terribly boring lecture, and you guys responded with boredom. And so good job. Let's turn off the camera and discuss it.